Welcome. And we're going to be covering some additional examples on lesson 5.4. So let's get started on that first problem. In total, I'll cover about 5 problems of additional examples. Okay, so we're asked to complete the table, then plot the pairs of values on the coordinate plane. The table we're given is, the first row is 3, 6, 9, 12, 15. And then the second row is 5, and then we need to complete those values to make equivalent ratios. So we want ratios that are equivalent to 3 to 5. So something to note, my pen's not in the right position. Okay. Something to note is that we're just counting by 3s up here. So we can take advantage of that. Because looking at that, if just by counting by 3s, that means it's times 2, then times 3, then times 4, and times 5. So down here, we're going to be counting by that value of the ratio, which is 5s. So it's going to be 10, 15, 20, and 25. So that final ratio is 15 to 25. Well, 5, 10, 15, 20, 25. Good job. And now we're to the graphing part, where in this case, we just are going to select a graph that matches those coordinates. Now, remember that the top row is x and the bottom row is y, and our coordinates are given as x comma y. So when we're looking at this point here, notice the scale, that's 3, 6, 9, and 6, 12, 18. So this point is 3, comma 6. Okay, well, that's not going to work. We need 3, comma 5. So this one's no good. I shouldn't have written it that big. Where's my eraser? Okay, so this one's no good. We'll clear that off because I got to scroll and that'll get in the way. Next up, this one right here. So this is 3, and then going up, it's 0. It's 3, comma 0, not 3, comma 5. So that option B does not work either. And then this one down here, this is 0, comma 369, so 0, comma 3. And this one is no good. So last one, D, the scale goes 3, 6, 9, and the vertical scale goes 5, 10, 15. So this first point is 3, comma 5. And that matches our table. So option D would be the correct one. And we've got it. Nice work. Let's clear our screen as we move on to the next problem. Okay. Second problem. A store charges $140 for every 10 bags of fertilizer a farmer buys. Now we want to complete the table and graph the values. And then the second part, part B, will be we want to find out how much would a farmer pay for 50 bags of fertilizer. Okay. So let's work on this table. Looking at this table, we see that the initial ratio is, right, store charges $140 for every 10 bags. Well, they put the 10 bags on the top row, so it's 10 bags for $140. And then notice here that we double this. This is times 2. 140 times 2 is 180, so that means we're just going to double our 10, which we get 20. And then you can see that we're counting by 10 each time, and so then we'll count up by 140 each time as well. So going down to our table, we can start filling that in. We have 10, 20, and then it's 140, plus 140 is 280, plus another 140 would be 420, plus another 140 would be 560, Now, if we were to add 140 to 560, we get 700, not 840. Okay, so what's happening here is we've gone up. This one was times, we'll go from here to here, it's times 3. And then from here to here is times 4. But going to this last one was not times 5. Okay, so what is 140 divided by 108? See, what is 840 divided by 140? Well, it's not 5. It's going to be 6. So our multiplier in this case, for this last equivalent ratio, is times 6. All right, so this is going to be 60. It's going to go from 40 to 60. All right, great job there. Now we come to graphing this. And looking at this, we want to find for 10 bags of fertilizer, it'll cost $140. So looking at this first option A, this goes by 10 along the x-axis, and it goes by hundreds. So this is 10, 100. Not quite right. We needed to be between this 100 line and the 200 line. Over on option B, this is on the 10 bags of fertilizers cost what looks like right around 140. It's halfway there. So this could be it. We're going to select that one and just check C and D. C, 10, and that's less than 100, so that's not going to work. 10 bags of fertilizers here costs, well, look at that. That is about halfway between 100 and 200. So let's see what's different. So we need to go back to our other points. 20, 300, or just shy of it. That's 20, 280. That's good. This one is 20, 300. So this point, this option D is not right because this is clearly on the 300 line, and we know that it's not on the 300. It's going to cost under $300. Let's see if any of the other points can confirm this. 30 and 400 and something, between 400 and 500. Well, looking at our table right here, 420, 30, call it 420. So you notice it's closer to 400. This one is more in the middle. Again, supporting the fact that it's option B. Now let's take a look at 40 right here. 40 bags, according to this graph, 40 bags cost $600. While looking at our table, 40 bags is going to cost $560. It should be plotted somewhere between the 500 and 600 line, which is, again, matches option B. So clearly, it's clear that from evaluating multiple points that option B is the best graph of that ratio table. We were correct. Great job. Now we need to answer the question, how much would a farmer pay for 50 bags of fertilizer? Remember, we didn't figure out 50 bags of fertilizer. We figured out 60 bags of fertilizer. So we can go up here and trace 50 bags to our graph that we selected. So here's the 50 line. Bring our pen back. And we go from 50 up to right there, 700. Okay. 50. Yep, that's 700. Okay. That's 700. We need to clear the screen. Go back. No, we don't want to be on our pen though. And go back here. So the farmer would pay $700 for 50 bags of fertilizers. On the graph, we trace the line from the 50 on the x-axis to the line. Then we trace from the line to the point on the y-axis intersecting at 700, right? So that's how we knew that it was $700. Great job. Okay, moving on to question 3. All right, here we are at question 3. And Gavin's going to make homemade cleaner using ½ cup of vinegar for every 2 quarts of water. Answer parts A and B. So A wants us to complete the table. Looking here, we see that the vinegar is the top row, water is the second. It was a ½ cup of vinegar for 2 quarts of water. Moving to the next row, the next column, excuse me, this is times 2. We're doubling this. So we double our vinegar, and it's 1. Okay. And then we're adding a ½ cup of vinegar. So we add a ½ cup again. So that means we just add 2 more quarts of water. 2 plus 4 is 6. So we have 6 quarts of water. And then again, we're increasing by 2. So we're just going to add another ½ quart up there. And 1½ plus half is 2 cups of vinegar for 8 quarts of water. So we've completed the table. Now we got to match the graph. We need to find where it's 1/2 cup of vinegar for 2 quarts of water, and then 1 cup of vinegar for 4 quarts, 1½ for 6, and 2 to 8. Well, looking right here, we can look at the halves, and that's great. But this right here is, this left side goes up by 2's. So this is ½ cup 2, 1 cup 4. So 1/2 to 2, 1 to 4, 1½ to 6, 2 to 8. That matches all of our points. B decreases. So that means as you add more vinegar, you decrease the number of quarts of water. That doesn't match our table. That's the same reasoning applies to D. And right here in C, it's for 0 cups of vinegar, you would need 2 quarts of water, which we know is not the initial ratio we start with. So it's option A for us. Now we're on to our second part, and we're going to use the graph to find out how much water Gavin would use with 3 cups of vinegar. All right, going back to look at our graph. We have to add 3 cups of vinegar. Here it is. We can trace this up from the x-axis to our line, intersects here, and then we move over to the y-axis, and we find that's at 12. So we would need 12 quarts of water for 3 cups of vinegar. Nice work. Okay. Excellent. We're moving on to question 4. Just 2 more to go. In this one, here we want to graph the table and graph the pairs of values. So we need to complete this table. Look at this table again. We jumped straight from 6 to 24, and then, well, I don't want to write it like that. So we're going from 6 to 24. Well, 24 divided by 6 equals 4. So we're multiplying our original ratio. I wrote that backwards. Yeah. Let's erase that. We're multiplying our original ratio by 4 to generate a new equivalent ratio. This is times 4. So 3 times 4 is 12. And we have a new ratio of 24 to 12. And then notice here, we start going by 6's each time. Well, remember our original ratio is 6 to 3. So if we're increasing by 6, that means over on the right, we're just increasing by 3. So we can go 12, 15, 18, and 21. Great job. I always love to see those words. Now we're going to call it. Now, this is, remember, this is x comma y. Whoops, I can't write. There we go. First column's x, second column's y. And we want to choose the correct graph. So 6, 3, that's our point. These are the points here. 6, 3, 24, 12, 30, 15, and so on. So we need to find a graph that represents those, all 5 of those pairs. On this first graph, it goes up to 24. That's 1, 2, 3, 4. So it's going to go by 6s. 6, 12, 18, 24. And then on the left of the y-axis, it's going to go up by 3s. 3, 6, 9, 12. So it's 6, 3. Then 24, 12. That's looking really good. 30, 15. 36. How convenient for us. It's option A. Now, we can look at some other options. Notice that option B doesn't work because the very first value is 0, 3, which is not an equivalent ratio. Okay? Our first ratio is 6, 3, not 0, 3. Then option C for us is, what is that? That's a 12, so that's 3, 6, 9, 12. So that's 3, 0. That's not going to work as either. And you'll notice the second point is not at 12, excuse me, should be at 24, 12. This is, our numbers are smaller here, where the x value should be larger than the y value, so that's not going to work. And then this one, it's 3, 6. So these are reversed. This one is reversed of what our actual thing is. See, we want 6, 3 and 24, 12, not 3, 6 or 12, 24. So this one's, it's got the x and the y's reversed. So check our answer. We got it. Great. Okay. Let's go to our final example question. But we got to clear our screen. Wipe that screen. And here we are. The graph shows the relationship between the number of pounds of dog food bought and the cost of the dog food. What are the coordinates of the point that represents the cost of 6 pounds of dog food? So we need to identify the coordinates. So the answer says the point that represents the cost of 6 pounds of dog food needs to be an ordered pair. So let's look at our graph. And we're looking for 6 pounds of dog food. So here's 6. See if I can manage to draw a straight line. So we tap right there and tap right there. And not drawing a straight line this time. Hey, but I did okay without it. So we go up from the x-axis to our line, and then we go from our line over to the y-axis. Oh, I'm doing pretty good. That's 9. So this point, remember, we want an ordered pair. Not that it's going to cost $9. That's great that we know it's going to cost $9, but we want the ordered pair 6, 9. Okay, so we're going to say we got that. We're done. Kept our writing, which is good for us. Get our parentheses for our ordered pair. There's 6. And then 9. And we hit, where's our check answer button? Fantastic. All right. We just covered 5 additional examples on lesson 5, which is like solving problems with graphs and using our ratio tables. So use those. They'll be helpful. And let me know if you have any questions.